Welcome back, everyone. Today we're going to be discussing the special right triangles. So these are triangles where we know the side ratios based on the angles inside of the triangle. So the first triangles we're going to talk about have angles that measure 45 degrees, 45 degrees, and 90. So these are usually called 45, 45, 90 right triangles. So the lengths of the legs are the sides that are not the hypotenuse, are directly related to the angle that's across from them. Since both legs are across from a 45-degree angle, that means the legs are equal. So in general terms, I can say that each of the legs are x units long. The hypotenuse equals the side length of the leg multiplied by the square root of 2. So here I would take my x and I would multiply that by the square root of 2. So let's see what happens when we add some numbers here. It's a 45, 45, 90 triangle. And let's say it's given that one of the legs is equal to 2. Well, since the legs are equal, they both equal 2. For the hypotenuse, we take the leg and multiply it by the square root of 2. So since the leg is too long, the hypotenuse equals 2 times the square root of 2. So that rule applies whenever the leg is a whole number, like 2. So the same thing here. If each of my legs was 6, and it's a 45, 45, 90 right triangle, the legs are equal, and that means they're both 6. And then my hypotenuse is that 6 multiplied by the square root of 2. And let's say we're given the hypotenuse. And it was 4 times the square root of 2. Well, since the hypotenuse equals the leg times the square root of 2, that means the leg is the number in front of the square root of 2. So here, that would be the 4. So if the hypotenuse is 4 radical 2, then each of the legs are equal to 4. So those problems were fairly straightforward since they were already in the side length ratios that are given for a 45, 45, 90. But let's look at some other examples where this is not the case. If I'm given a leg that is 7 root 2, well, the legs are equal, so both of them are 7 root 2. But remember, the hypotenuse equals the leg times the square root of 2. If I replace the leg with 7 root 2, I get 7 root 2 times root 2. If I'm multiplying the square root of a number times itself, so the square root of 2 times the square root of 2, you multiply the numbers inside. 7 times the square root of 2 times 2, which is the 7 times the square root of 4, and the square root of 4 is 2. So take this out of this radical and multiply 7 times 2, and your hypotenuse is 14. So let's try another one of those. Given a 45, 45, 90 right triangle where the leg is 6 radical 3. Of course, both legs are 6 radical 3. But to find the hypotenuse, we have to multiply the leg by the square root of 2. Okay. So we're multiplying the two numbers in the radicals. 6 times the square root of 3 times 2, or 6 radical 6. Well, the square root of 6 cannot be simplified, so this is the final answer for our hypotenuse. There are a couple more situations you could be given. Excuse me. What if you're given a hypotenuse that is a whole number? So for example, our hypotenuse is 6. Well, according to our ratios, the hypotenuse equals the leg times the square root of 2. So in order to solve for the leg, we're going to divide both sides by the square root of 2. This means we get 6 divided by the square root of 2. So instead of multiplying the leg, we're going backwards and dividing the hypotenuse. Now, you may be asked to rationalize a denominator. That means that we want to not have a radical in the denominator. So in order to do this, you're going to multiply the fraction by the denominator over itself. So we multiply 6 over radical 2 times radical 2 over 2. And remember, if I multiply the square root of 2 times the square root of 2, it simplifies to 2. So we get 6 times the square root of 2 over 2. Now 6 over 2 can be simplified. So my side lengths are 3 radical 2. Those are the lengths of my legs. but there is a simpler trick. So you notice how I could get from 6 to 6 to become 3 root 2. The other way to do this is to divide the denominator by 2. Not the denominator, hypotenuse. And multiply it by radical 2. So let's take a look at another example. If I had a 45, 45, 90 triangle and I'm given a hypotenuse of 10, you could go through all of this work, or we can do 10 divided by 2 times the radical of 2. And 10 divided by 2, of course, is 5. So we get legs that are 5 root 2 long. Now in trigonometry, we're going to talk about the unit circle, which, as I mentioned last time, means that the hypotenuse equals 1. So we can follow the same process that we just completed using a hypotenuse of 1. So the leg equals the hypotenuse divided by 2 times the square root of 2. In this case, the leg equals 1 over 2 times the square root of 2, and that simplifies to radical 2 over 2. So this is going to be important when we get into the unit circle, so just make a note of this. The right triangle is a 30, 60, 90 right triangle. Okay, here the legs are not equal because the side across from 30 is going to be smaller than the side that's across from 60. So you need to be careful that you're looking at which leg you are solving for and which leg you're given. So if the short leg is given, and we'll say that's x, that's across from the 30. And if you're confused about which side is across from the 30, just like we did in geometry, put your pen or pencil on the 30 and draw a line through the triangle. The side that you hit is the side that's opposite. So if my short leg is x, the hypotenuse is double or 2 times the shorter leg. So in this case, it's 2 times x. And then the longer leg, which is across from the 60-degree angle, equals the short leg times the square root of 3. So since the short leg is x, my longer leg will be x radical 3. So let's say we're given the short leg and it's 3 long. The hypotenuse is 2 times that length, which is 2 times 3, and the hypotenuse equals 6. Then for the longer leg, you take the shorter leg and simply multiply it by the square root of 3. So we'll have 3 radical 3 for our longer leg. Let's try another example. If the short leg is 7, what would be my hypotenuse? If you said 14, that's right, because the hypotenuse is double the side that's across from 30. And how do we find the longer leg? Well, you take the shorter leg and multiply it by the square root of 3. Now, if we're given the hypotenuse, and let's say our hypotenuse is 8, the first thing you do is divide by 2, and that equals the shorter leg, which is across from the 30. And that means my shorter leg across from 30 is 4. Multiply the shorter leg by radical 3 to get the longer leg. So 4 times the square root of 3 gives me the leg that's across from 60. Okay. They could also switch the positions of the angles on you. So you need to be careful that you realize the shorter leg is always across from the 30, no matter where the 30 is located. So this bottom leg is now my shorter leg. What if we are given the longer leg? And let's say it was 7 radical 3. First, you find the shorter leg, and that's the number in front of radical 3. So the shorter leg here equals 7, and that goes across from the 30. Next, to find the hypotenuse, we double the shorter leg. So that's 7 times 2, and my hypotenuse will be 14. And once you do enough of these, you're going to start seeing patterns and the same numbers over again, so it should become more comfortable. Okay, 2 more examples. I switched up my angles again, so this is the shorter leg. And what if the hypotenuse was 5 radical 2? So the first step is still the same. To find the short leg, we'd take the hypotenuse and divide it by 2. 5 root 2 divided by 2. Actually, let's change this to an even number. If it was 6 radical 2, then my short leg would be 6 root 2 over 2. Simplify here, and the short leg is 3 radical 2. And that has to go across from the 30. Now to find the longer leg, it's still the short leg times radical 3. So watch out here because I already have a radical in the shorter leg. So we have 3 times the square root of 2 times the square root of 3. So we multiply the numbers inside a larger radical, and my longer leg is 3 radical 6. Okay, so finally we have to talk about when the hypotenuse equals 1, since, like I said, we're talking about the unit circle, and in the unit circle, the hypotenuse is 1. So, how do we find the shorter leg when we know the hypotenuse? We divide it by 2. So I have 1 divided by 2, which equals 1/2, and that goes across from the 30. To find the longer leg, the shorter leg times the square root of 3. So we have 1/2 times radical 3, which is radical 3 over 2. So remember that you have to show all of your work on the worksheet in order to get full credit for your homework. I'm here during office hours. You can also make other appointments to meet with me. Please reach out if you need help. Keep making up those late assignments until you get the scores that you're happy with, and be sure to send me an email when you're done. I look forward to hearing from you. Have a good one. Hope you're all staying safe.